Right. Greetings to all great hosts. Thank you for joining us. We are on lesson 14, which is basically on determining the equation of a drawn graph. If you look at the previous sessions that we had, we were sketching graphs. We managed to sketch a linear graph. We sketched a quadratic function, which we call the parabola. We went on to the hyperbolic function, and up to now, sure, we are all able to sketch those particular graphs. Over and above that, we also looked at sketching of a logarithmic graph and an exponential graph. Okay, right, that was sketching. We were given an equation, and the question would say sketch this particular function. Right. Now, we want to switch over to the reverse process where you are now given the um, the drawn graph, then they'll say determine its equation. Okay, right. So you'll be given a sketch graph, then the question would be calculate or determine its equation. Okay, right. This is purely revision of your grade 11, but it's highly examinable at grade 12. Okay, so I'm going to start with basic sketching in this session. I'm going to be looking at determining the equation of uh, a drawn linear function and a drawn parabolic function, okay, or quadratic function. Right. Now, let's turn to our board. Let's turn to our board and let's start with the sketch, the determining of the equation of a drawn linear graph. Okay, right. Determining the equation of a drawn linear graph. Okay, right. You'd realize that in most exams, you'll be asked to calculate or determine the equation of a graph which is drawn. So we're trying to build on that concept so that when you are faced with such in an exam, you will not have problems. Okay, so I'm going to start with the linear graph. How do you know that this function is linear? Remember, a linear graph is a straight line graph, and this is deduced from the equation. Remember, you identify the equation by the highest exponent of x. If the highest exponent of x is 1, then the equation is linear. If you draw that, you come up with a what? A straight line. So once you see a straight line drawn, then you know that this is linear. Okay, right. Determining determining the equation the equation of a drawn determining the equation of a drawn graph or drawn sketch graph. Okay, right. I'm going to start with the first one, which is equation of a drawn linear graph or straight line graph. Okay. Okay. Now, I'm given something like this. Let's look at a quick illustration or example there. It says, I've got my Cartesian plane like this. Then there you go. This is f of x passing through -1 there, and 2 there. Okay, right. Question says determine the equation of f. Right. I want to come up with the algebraic equation of f. Right. Now, how do I come up with that? There are two basic methods that you can use to come up with the equation of this expression. Right. There are two basic equations. Right. Now, the first method that we can use, the first method is what we call the dual intercept method. Dual intercept method. Now, the dual intercept method is a basic method which tries to point us to the points where the straight line cuts the x-axis and the y-axis. Now, the dual intercept method says once you get the x-intercept and the y-intercept, for you to come up with such an equation, you simply come and say x over a plus y over b is equal to 1, where a is the x coordinate, the x-intercept, and b, it is the y coordinate at the y-intercept. So in this case, you can see that a is equal to -1 and your b is equal to 2. Substitute that, you then say this is now x all over -1 plus y all over 2. This is equal to what? 1. From there, we can now take this expression to standard form by making y subject to the formula and present your equation in the form y equal to mx plus c. But how do you then do that? If you look at this expression, it is it is fractional in nature, so we have to clear off the denominators. How do I clear off the denominators? I'm supposed to look for the LCM, then multiply each and every term with your LCM. What is our LCM in this case? Our LCM in this case is 2, so I'll multiply each and every term by 2. So this is x over -1 times 2 plus y all over 2 times 2 equal to 1 times 2. Multiply each and every term with your LCM to clear off the denominators. This becomes -2x plus y equal to 2. Now make y subject of the formula. How do I do that? Transpose -2x, it becomes y equal to 2x plus a 2, right? That will be the equation of the drawn linear function. Okay, right. Now, looking at this is the first method that we have. Someone can choose to say, let me use our analytical geometry techniques to come up with the same equation. Right. In analytical geometry, I'll come and say method 2 from our analytical geometry. Analytical geometry techniques. Right. How do I come up with the equation of a straight line? Right. This is a basic straight line, and you know that from analytical geometry, we're saying for us to come up with the equation of a straight line, you need the gradient, you need a point where this line passes through. Okay, so you can say y minus y1 is equal to m in bracket x minus x1. Okay, right. Now from there, I need a point where this passes through. We need a point where this passes through. And in this case, I've got point 0 and 2. Someone can also choose to take -1 and 0. It's still fine, as long as you get a point where it passes through. Do I have the gradient? Right. Remember, analytical geometry says whenever you want to come up with this equation of any straight line, you need the gradient and you need a point where this straight line passes through. So in this case, I've got a point where it passes through 0 and -2, but I don't have the gradient. So I have to go and calculate the gradient. Right. Calculating gradient, remember, it is change in y all over the change in x. y2 minus y1 all over x2 minus x at 1. In this case, that would be 2 minus 0. This will be 0 minus minus 1, which is going to be 2 all over 1. So the gradient is equal to what? 2. I'll then take the gradient and the point where this passes through, insert it into the equation of a straight line. So this will be y minus a 2 equal to 2 in bracket x minus a 0. So it's y minus a 2 equal to 2x. Y is equal to 2x plus a 2. That would be the equation of a drawn straight line graph. You can see that with two methods, it agrees to the same answer. Okay, right. Let's go to the next session, where I'm going to be looking at what? Deducing or determining the equation of a drawn parabola. Okay, right. Equation of a drawn parabola. In this case, you are supposed to identify a parabolic function or quadratic function when it's drawn. Right. Now, if you look at your lower grades, remember there are two types of parabolas. One which is cup-shaped and the other one which is bell-shaped. In some books, it's described as a sad face and a smiling face, or some teachers will present it as a graph which is concave down and the other one which is concave up. That is the graph of a quadratic equation. Remember, a quadratic equation, its graph is called a parabola, and it comes in two folds, either bell-shaped or cup-shaped. Okay, right. Now, so once you see something which is concave down and something which is concave up, or something which is bell-like in shape or cup-like in shape, then you know that this is the graph of the quadratic equation, or this is called a what? A parabola. Okay, right. So let's look at determining the equation, determining the equation of a drawn parabola. Okay, right. Right. Just by looking at a sketch graph, one should be able to tell that this is now a parabola. Okay, right. We were sketching this in the previous session. I'm sure you also appreciate how a parabola looks like. Right. Now, there are two main cases that you're supposed to consider when you're trying to deduce the equation of a drawn parabola. Right, the first one, I'll call it case number one. Right, the first case, it depends on what you are given. Once you see a parabola drawn, the next thing is to assess the graph, look at what you can deduce from the graph. What exactly are you given? Right, so if you are given, when given two roots, remember roots are just x-intercepts. So if you are given two x-intercept or two roots, and at least a point, at least a point where the parabola or where the graph passes through, once you've got two roots and at least a point where the graph passes through, you are going to take the structure, or the structure that we are going to use to deduce the equation is y equal to a in bracket x minus the first root, x minus the second root. Or you can also find it in some books as a x minus x at 1 in bracket x minus x at 2, which is basically the same thing. So once you identify that this is a parabola drawn with the roots given, this is the structure that you are going to use to come up with the equation of the drawn graph. Okay, right. Let me give you a quick example there. Right, let's look at an example. Right. Given the graph of f of x below, so I am given a graph of f of x drawn below. There is our sketch graph. There you go. Right. Got a graph like this. This is 1, that's 2. Right, and that is given to be 4. Right, this is the graph of your f of x. Now, the basic question says determine the equation of f of x in the form f of x equal to ax squared plus bx plus c. In other words, they want this parabola in its standard form. Right. Now, just analyzing the sketch, if you look at the sketch closely, what am I given? This is a cup-shaped parabola, or a parabola which is concave up. What am I given on the parabola? We are given the intercepts or the roots. Both of them, the first intercept and the second intercept, and at least another point where this graph passes through, which is a 0 and 4. So I'm given the two roots. So since I'm given the two roots, definitely I'm going to take the structure a x minus the first root, x minus the second root to determine the equation. So this structure is going to guide me. It's going to help me come up with the equation of the drawn graph, identifying that I've got the two roots given, right? So I'll come and say this is going to be equal to a in bracket x minus, what is the first root? My first root is at x equal to 1, x minus the second root is a 2. So y is equal to that. Now, the next thing is to get the value of a. Remember, a is a constant. An equation is always a relationship between x and y. So a is a constant. I have to look for a. How do I get a? I'm supposed to use another point where the graph passes through, and that point is at x equal to 0 and y equal to 4. So I'm going to substitute. Where there's y, I'll put 4. Where there is x, I'm going to put 0. So simplify, this is 4 equal to a times -1 times -2, which is basically 4 is equal to 2a. I can divide both sides by a 2. Therefore, a is equal to 2. Once I get a as 2, I can now take this, plug it back into the expression, right? So allow me to come this side and say, therefore, this equation y is equal to what? 2 in bracket x minus 1 x minus 2. Right, this is an equation of a parabola, but the examiner simply says determine the equation in the form y equal to f of x equal to ax squared plus bx plus c. In other words, in its standard form. So I have to open the bracket and present it in its standard form. So this is going to be 2 in bracket x squared minus 2x minus x plus a 2, something like that, which is going to be 2 in bracket x squared minus 3x plus a 2. Open the brackets now. This is 2 x squared minus 6x plus a 4. So my f of x in standard form is what? 2x squared minus 6x plus 4. That is the equation of a drawn parabola, considering the first case when you're given two roots and at least a point where this passes through. Right, I'm now looking at case number 2. There are only 2 cases that we are supposed to consider, and the examiners will be playing around with these 2 cases. Now, case number 2, very simple. The second case is when you are given, when one is given, when you are given the turning point, and at least one other point where the graph passes through. Okay, so in this case, you are supposed to analyze the graph which is given. After analyzing the graph which is given, one is supposed to be able to pick that in this case, I'm given a turning point and at least another point where this graph passes through. Once you identify that, you can now take the structure. For you to come up with the equation, you take the structure y is equal to a in bracket x minus that whole squared. So whenever you are given a parabola drawn, and the examiner wants you to extract or to deduce its equation, there are only 2 cases that you are supposed to use. Either you are going to use, or you are going to identify that I'm given 2 roots and at least one point where the graph passes through, or you are given the turning point of that parabola and at least a point where the graph passes through. Okay, right. Now let's look at this quick example. Right, let's look at this quick example. Example number 2. Right, I am given the graph f of x below. Okay, let's consider f of x drawn below. So you are given a graph of this sort. Right, and there you go. Right, on my graph, I'm given the turning point to be -1 and 8. And there is another point where this passes through, which is 2 and -10. Right, now I'm supposed to, question says determine the equation of f of x. Determine the equation f of x. Right, now I'm going to say, for me to come up with the equation of f of x, what am I given? I'm given a turning point. So in this case, I'm given a turning point at least another point where it passes through. So it means I'm going to say a in bracket x minus p whole squared plus a q. Right, now what am I given? The coordinates of the turning point. At the turning point, it means p is equal to -1 and q is equal to what? 8. So I'm going to substitute that into my expression. So it means this is y equal to a in bracket x minus -1 whole squared plus 8, which is y is equal to a in bracket x plus a1 whole squared plus 8. Okay, the next thing is I'm supposed to come up with the value of what? A. How do I come up with A? I'm simply going to say, let me look for another point where it passes through, and that point is at x equal to 2 and y equal to -10. So I'll substitute now and say -10, right? It's -10. So I'm going to say y is negative 10 and a is 2. So this is 2 plus 1 all squared plus 8, which is then going to be negative 10 minus 8 is equal to a in bracket 3 all squared. In other words, this is going to be negative 18 equal to 9a. Okay, allow me to take this over, and this will be what? Negative 18 equal to negative 9a. Divide both sides by negative 9. There you go. That cancels. It means a is equal to 2. I'll then substitute a back into the expression. Y is equal to 2 in bracket x plus a1 all squared plus 8. This is equally an equation. Since they did not ask us to say leave it in standard form, you are also allowed to leave it like that. But if they say leave this expression in its standard form, you are supposed to open the brackets and write it in the form ax squared plus bx plus a c. Okay, that is how you deduce the equation of a drawn parabola. Okay, there are two main cases that you're supposed to what that are supposed to use. Right. I'm now going to give you another example on this, where especially in grade 12, they know that this is basic. This is what you're supposed to acquire from your grade 11. So in grade 12, they will try to create scenarios where they'll probe you to jump out of the box and look at things from a different perspective. Remember, we are building scientists. You are not supposed to be in a closet. These are only two guiding principles that you are supposed to use, but it does not mean that whenever you are faced with an equation, whenever you're faced with determining the equation of a drawn parabola, it's always and it's all obvious that you're going to use this. They will always try to push you out of your comfort zone. They will try to push you from the norm so that you can start thinking and cherish our mathematics. Okay, right. So I'm going to give you example number 3, and I'll show you how things can turn out to be a little bit different, but applying the basics or the basic cases, which is case number 1 and case number 2. Okay, let's look at this example. Let's look at this example together. Okay. Right. Looking at this example, one can give you something like this. Given that f of x is equal to ax squared plus bx plus a c. So it means this is f of x is a parabola. So given that f of x is equal to that, with the graph of f drawn below. Okay, right. We've got something like this. Let's look at this together. Okay, let's look at this graph. Okay, we've got a cup-shaped parabola of this sort. Okay, right. I'm given this to be -1. Then there is a dotted line. There you go. And this dotted line is labeled to be x equal to 1. Okay, we also have another point there, which is 0.4 and 5. There you go. Okay, now this is a parabola. We can all see that this is a cup-shaped parabola, or you can call it a smiling face. Okay, right. Now, if you look at this parabola, the question is basic. Determine the equation of this. Determine the equation of f in the form f of x equal to a x squared plus bx plus a c, which is the standard form. Okay, now determine the equation of this parabola. What am I given on this parabola? That's the most important thing, because I'm supposed to appeal to my two basic cases, right? Now, those cases were, the first one, if you're given the roots and at least a point where it passes through, you can use y equal to a in bracket x minus root 1 in bracket x minus root 2, right? If you're given the turning point and at least another point where it passes through, that's case number 2, y will be equal to a in bracket x minus p all squared plus a q, right? Now, if I analyze my graph, look at this. I only have one root. I don't have the other root. I'm only given -1 as the only root. Okay, right. Now I will look at the turning point. At the turning point, I don't have all the coordinates. I can see that dotted line, which is labeled x equal to 1. And that dotted line denotes that this is the axis of symmetry, right? So in other words, at the turning point, I only have one x entry. I don't have the y entry. So both cases fail. Now, since the two cases are not applicable, then I'm supposed to make calculations so that I can deduce some of the features that I can easily calculate from the information that I'm given. Right. Now, how am I going to do that? That's the most important thing, right? If you look at this, the dotted line is the axis of symmetry. An axis of symmetry divides the graph into two equal segments. That's an axis of symmetry, right? Now, so in this case, it means x equal to 1 casts the parabola into two equal segments. So since I'm given one root, which is -1, I can use it to deduce yet another root, which is in your first quadrant, right? Now, look at this. How am I going to do that? Very simple. I'm going to come up, or I'm going to count the number of units that I'm going to take to move from -1, the first root, to the line of what? To the axis of symmetry. How many roots are those ones? You can see that from -1, definitely you go to 0, which is the origin. From 0, you go to 1. So in other words, from -1 to the axis of symmetry, we moved 2 units. So since it's an axis of symmetry, it means I'm also supposed to move 2 units from the axis of symmetry to the next root. So it means that will be what? 1, and that will be 2, and that will be 3. So the other root is actually what? 3. As basic as that. Someone can choose to use the midpoint theorem or the midpoint formula, sorry, from your grade 10 analytical geometry. In this case, it means x equal to 1. It is what? The x coordinate at the midpoint. So someone can just say x at the midpoint is equal to x at 1 plus x at 2 all over 2. I'm using the midpoint formula from your grade 10. Okay, x at the midpoint is given as 1, which is going to be equal to x at 1 is -1, it's given. X at 2, it's x, we don't know, all over 2. Now solve for x. Cross multiply, that will be 2 equal to -1 plus x. Making x subject, we can easily see that this is going to be what? Transpose -1, that will be 3 equal to x. So you can also calculate the value of the other root using that method, or you can count physically on your Cartesian plane, like what I did with the first method. So in this case, I now have 2 roots and at least a point where it passes through. So once I've got 2 roots, it means I'm going to take the structure A in bracket x minus root 1, x minus the second root, where the first root is -1, so it's x minus -1. The second root is 3, so it's x minus a 3. So it means this is going to be a in bracket x plus a 1, x minus a 3, something like that. Okay, now the next thing is to look for the constant a. How do I get the constant a? Always, constant a, you're going to look for another point where the graph passes through, and that point is at x equal to 4 and y equal to 5. Now substitute, this is 5 equal to a in bracket 4 plus a 1 in bracket 4 minus 3. Wherever there's x, I'll put 4. Wherever there's y, I'll put 5. So this is 5 equal to a in bracket 5 times 1, which is now 5 is equal to 5a. Divide by 5 both sides. It means a is equal to what? 1. If a is 1, I'm going to substitute it back into my expression, which is going to be what? Y is equal to 1 in bracket x plus a 1, x minus a 3, which is going to be, now I'm opening the brackets, x times x squared, x times negative 3, it's what? Negative 3x, 1 times x, it's x, 1 times negative 3, which is negative 3. So it means this is going to be y is equal to x squared minus 2x minus a 3. Okay, so it means my function f of x is equal to x squared minus 2x minus a 3. That is the equation of the drawn parabola. As simple as that. And this is how you deduce the equation of a drawn parabola. Right, I'm going to go to the next class. In the next class, I'm going to be looking at how you can deduce the equation of a drawn parabola. And I'm also going to incorporate parabolas there so that you can keep interrogating these things until we come to perfection. It is important for you to be exposed the more on this section, and we are going to give you more and more problems so that you can approach different variations that examiners can create. And I hope and pray you mastered this concept, and it is important for you to keep in touch with us as we are unfolding this concept. Let's move together and keep following us. We are going to unpack. We are almost at the end of this section. Keep following, and if you happen to find or to get challenges either from past examination questions, send it to us, then we'll try as much as possible to assist you. Thank you so much for your time.